Welcome to Onshape for Makers. This is not a speed modeling contest. This is not an engineering contest. This is how would a guy actually draw one of these things if he wanted to make the part and take it to the shop. It's about using Onshape for non-engineer guys who are just trying to make stuff. The part for tonight is this little strange looking piece. It is from a website called totaltoby.com or a YouTube channel by the same name, Too Tall Toby. Amazing content place to go look and find hundreds of models, all kinds of things over there. You really need to go look, but let's talk about how you would build one. This one, if you really look at it, has a ball on the top up here, has a dish on the bottom with a flat spot. It has a tower and it has a taper. If we build it the easy way, we will build this lower portion first, then we'll do the ball, then we'll start on this rectangular section and do it, and then we'll make a small insert up here and then combine all the parts into a single part to finish it. By breaking it into subtasks, it's a lot easier to manage. So let's go over to Onshape. Okay, let's get started with our Onshape free account. We'll go pull down the hamburger menu, workspace, millimeters, 0.12 grams, 0.12 check mark, select front, click front over here, select sketch, and we're ready to sketch. Now, what we're going to sketch is this very bottom part here, the flat part and the arc. Hopefully you captured a copy of the drawing. If you didn't, back up right quick and capture one. Under the arcs, one of the arcs is a center point arc. We will pick the Y or Z, I suppose it was Z, plane, pull down, click somewhere. It doesn't make any difference where, just click and make an arc like that. Hit escape, come up to constraints. We will select horizontal, which is there, and we will select this point and that point, and that gives you an equal arc. Now, if you will notice, the width of the arc is 35, so we will go up to dimensions, select here, pull down, that's 35. The bottom of this should be tangent with this plane, so we will check that plane, that plane. Oh, I forgot to say, we went up here and selected tangent and then did all that. So we select this, select that. That will bring it up and force this to be tangent. And then we can go to dimension, and from this dimension to that dimension on the model is 3 millimeters. And that gives you your base curve. Now, to get the rest of it, we can come up here to rectangle, select center point rectangle, catch this axis, and that will lock the rectangle into equal, and then we'll establish a incidence relationship there, and all we have to do is put in this value, and that value is 3. And we have finished that part of the sketch. Now we have up here high up a circle, so we will select circle. We can put it in anywhere we want to, it doesn't matter where you put it. And that is an 11 millimeter circle. And if you look at the blueprint, it is 62 millimeters from here to the center of that. So we'll come over here and type in 62, and that establishes that. Now we need a rectangle and we need the ribs that go in this. To do the rectangle, let's go back to the center point rectangle. Select anywhere in here, it makes no difference. Pick it, come down, pick this. Don't let it pick the corner, pick somewhere inside and just click it, and then hold your mouse to the left and you'll notice that dimension is 46. Enter. And this dimension here is 16. Enter. And that's that feature. Now the only other feature we've got is there is an inset. To get the inset, we come with another center point rectangle, pull it down till it's on, sees that line, click. The width of that is determined off of this edge, so we'll get it, but the height of it is determined off the top. So we will hit escape and not put either dimension in. Now go to dimension, select this, select that, and the answer to that should be 3. And then select one side of your second rectangle, one side of your first rectangle, and the answer is 3. And that gets us this inset right here. Now we're going to extrude it, and to extrude it, we're going to extrude this face out to the full width, and then we will extrude the inset face out to the shorter width. And because this is a symmetry, we will extrude it in symmetric fashion going forwards and backwards, and we will get the entire part in 2 extrudes. The only thing we have left is we need to do that, and the way we're going to do the ribs is we're going to come up a little ways, touch the circle, go straight across, make sure you have a dotted line, come back down, click that. And then we'll go to constraints and we will say equal, and we will make this side equal with that side. That's probably not necessary, but it makes me feel better. Anyway, go to dimension. The angle between these two sides is 30 degrees. And this forms 2 of the ribs. The other 2 of the ribs come out towards us and we don't see them, but we're going to pull a little trick in a minute and get that. We need to draw 2 more lines. We need to draw a line vertically through the center of the circle so we can do a revolve and escape. And we need to come down and draw a line through the center of the button head at the bottom so we can do a revolve. And we're ready to go. So green check mark, go to revolve, select these 2 sections, go to revolve axis, select that line, and there's the button. It's green check mark, go over to your sketch disappeared, go over to sketch, do show sketch so we can see it again. We're going to go up to the top, we're going to do revolve, select half a circle, revolve axis, the middle of the circle, and there's the ball that's on top. The only thing we lack to finish the ball, there's a little flat spot on it, but we will do that later. We could have done it before we sketched it, we just didn't do it. We might go back and do it that way. Anyway, now what we need to do is we need to extrude the outer part. So we will select extrude, select that part, turn it a little bit sideways, select symmetric, that means we're going equal directions, And the width of that is, yeah, it is. I actually saw that dimension, 16. So we will type in 16, and that gives us green check mark, everything but the center. So now we can go to extrude, we can select the center, and we can select symmetric, and the center is 1.5, or it's each direction, or 3 total. And we do green check mark using add, and that makes 2 parts. We have this part and we have this part, and we will combine them in a minute. The only thing we need to do now is put in these ribs, and we have the profile drawn for one of these ribs, so we will do a symmetric extrude and get this, and then we will do a copy and rotate 90 degrees to make these out of that without having to actually construct anything. To make it easier to see, go to part 1, do a hide, go to part 2, do a hide, and now all we have is a sketch left. We can go to extrude, we can select the parts in symmetric, and they're 3 millimeters, like that, and make sure they're new parts, and select complete. Now we need to rotate and copy. To do that, we will come up here, and on the toolbar you'll see something called transform. Select transform. It says entities to transform. We want to transform that. We want to do a copy part, and we want to do a rotate. Select axis, select the line through the middle of the circle. That's how we want to rotate it, and type in 90 degrees, and now we have a second set. Now if you'll notice, it made 2 separate parts over here, but we can fix that by coming up here to Boolean, select part 4, select part 3, check mark, and that made 1 part out of that. Now if you come and you turn on the display for part 2 and part 1, you'll see we have pretty much finished except for the flat on top. To combine those, we can go back to the Boolean function, select part 3, part 2, part 1, check mark, and now we have 1 part. The only thing we need is that flat spot, and we can either do a second sketch, or what would be just as easy is we can double-click sketch for the original sketch, push in as in normal, and it will turn around until we have the view. In this drawing, it is 72 millimeters from the bottom of the button to the flat. So what we will do is we will come up here, do a center point rectangle, select this line and just pull straight up until you have a dotted yellow line, click, pull out, pull down, make a rectangle. I don't know, I'm going to make this one, say 8 and 25. It doesn't make any difference what size it is as long as it's big enough. Now, if you remember, from the very bottom of the button, which is here, to the flat spot is 72, so we're going to dimension, and we're going to dimension this at 72, which will pull that down to cut off part of the button. 72, boom, like that. Now, what we have done is we have got rid of part of the button, and the reason we got rid of it, if you go back and double click Revolve 1, you'll see that when we did the revolve, we picked parts of two sketches, which was this and this, but this part isn't picked, so because it's a new part since we did the revolve, and the revolve doesn't know about it. So that is the part. If you do a shift and a P as in Paul, it will clean up all of the sketches, all of the planes, do everything, and there is your complete part. The mass of the part is determined by the material, and the material we're using is a custom material, and it has a density of, let's go to library, go to Too Tall Toby material. To add this library, go over to Too Tall Toby's website and look, not website, his YouTube channel, and look for his little video on how to add this custom library. It has the three materials he uses on all of his parts set to the right value. Not all systems, including this one, use the same one he does, so you'll need his library. Anyway, once you get the material set, you can come down to the bottom right-hand corner and click the scale, which says Display Mass Properties. Click Part 1, and it should say 12.22 grams. According to the drawing that Toby put out, it is 12.22, so we have successfully replicated his work over here. Certainly not as fast as they do in the speed modeling, but then again, we're making parts, we're not speed modeling, so this was designed for guys that want to make parts and print parts, and hope you enjoyed it. I sure enjoyed teaching it. Talk to you guys later.